Every time you flip a switch, you're plugging into this gigantic, incredibly complex electrical grid. So today, we're going to pull back the curtain on one of its most important, but almost completely invisible components. It's a device that's like a silent guardian, working 24/7 to prevent total chaos on the power lines. Okay, so let's just dive right in with a really basic but super important question. In any electrical system, the ground is basically your safety net, right? It's the path of least resistance for electricity to flow when something goes horribly wrong. So, what happens when that safety net just isn't there? Well, to get that answer, you really have to understand the huge difference between a system that has a ground connection and one that doesn't. And believe me, the difference isn't small. We're talking night and day. It's the difference between stability and total chaos. This comparison really lays it all out. A grounded system, it's stable, it's predictable. But an ungrounded system, which you might find in some older industrial setups called delta-connected systems, well, that's a complete wild card. See, with no path to ground, if there's a fault on one wire, the energy has nowhere to go. It actually surges back into the system, creating a massive voltage spike, a really dangerous overvoltage on the other two wires. The whole thing just becomes incredibly volatile. This is the exact puzzle that engineers were up against. I mean, you can't just take a wire and stick it in the dirt and call it a day. You have to somehow create a stable, artificial grounding point out of thin air. And for that, you need a really, really clever solution. And here it is. This is the hero of our story, the Zigzag Transformer. It's this super specialized piece of equipment designed to do one thing and one thing only: solve this exact grounding problem. At its core, its whole job is to create an artificial neutral point. Just think of it like retrofitting a critical safety feature onto a system that was built without one. It literally establishes that safe path to ground that was missing all along. Okay, now for the really cool part. Let's look inside and see the magic. The name Zigzag isn't just for fun. It literally describes the completely unique, almost counterintuitive way the coils are wound inside. And that pattern, that's the key to everything. So it's this interconnected star winding that makes it so special. Instead of a simple, straightforward connection, the winding from one phase actually gets linked to the winding of the next phase. It creates this zigzag pattern. Under normal conditions, the forces are all perfectly balanced, creating this kind of electrical standoff. But it's this exact setup that unlocks a powerful ability when things go wrong. Right, so when the grid is humming along just fine, the magnetic forces inside are perfectly balanced. They just cancel each other out. It's kind of like two people pushing on a revolving door from opposite sides with the exact same force. Nothing moves. The transformer just sits there, completely idle, drawing almost no power. It's basically invisible to the system. But the moment a ground fault happens, that beautiful balance is completely shattered. The system is suddenly unbalanced. All at once, those magnetic forces no longer cancel out, and the transformer instantly switches from being a high-resistance roadblock to a low-resistance superhighway, giving that dangerous fault current an immediate, safe path straight to ground. And that's the genius of it. It's a passive guardian. It does absolutely nothing 99.9% of the time, but it's always ready to spring into action in the millisecond a fault happens, protecting the entire grid from a potentially catastrophic failure. So we know how it works in theory, which is awesome. But now let's look at where this amazing device is actually put to work in the real world. Because this isn't just some theoretical gadget. It's a total workhorse in some of the most critical parts of our modern electrical grid. So beyond its main job of grounding, that unique design makes it perfect for a bunch of other really tough jobs. Like, it's great at filtering out this electrical noise called harmonics. These are unwanted currents that can really damage equipment. It also protects sensitive gear in renewable energy systems and helps balance out uneven loads. And you can see it right here. System grounding is still its #1 job, for sure. But look at how important its other roles have become. A full quarter of its use is for cleaning up power quality, and another 20% is all about making sure our green energy, like wind and solar, can connect to the grid safely. Now, this is seriously cool. That same zigzag winding is incredibly good at trapping specific kinds of electrical distortion, what they call triple harmonics. These are nasty currents, often created by our modern electronics, that can make transformers overheat and equipment fail. The zigzag transformer just acts like a sponge, soaking them all up before they can pollute the rest of the grid. It's also absolutely essential for modern wind and solar farms. The inverters they use to convert DC power to AC are incredibly sensitive. A zigzag transformer gives them a stable ground reference, which protects them from faults and makes sure all that clean energy they produce gets delivered safely to us. So, the main thing to take away is this. Unlike a normal transformer that just steps voltage up or down, the zigzag transformer is a highly specialized safety device. It's a problem solver, designed from the ground up to make our power grid stronger, more reliable, and a whole lot safer. And that kind of brings us to a bigger idea, right? The zigzag transformer is just one of many ingenious, often invisible solutions that are quietly working behind the scenes. It really makes you wonder, what other hidden heroes are out there, silently making our modern world possible?